Hi, this is Sam going with Siemens PM Software. In this NX quick tip video, I will quickly review the specific workflow of bringing scanned files using STL file format into the NX and create features using convergent modeling methodology. Realizing that anytime when users bring actual scan data into NX, the relative scan surface display may not be totally smooth. There's some specific workflow within the NX reverse engineering function enable users to clean up any irregularities or noise in the geometries. Showing users how to do that will be another quick tip video. Let's quickly import those STL files. Using the STL import command, users will have the option of selecting convergent body, NX facet body, or JT facet body. The last two options will yield only viewing capabilities within NX modeling commands. So this new convergent option will provide usage of NX modeling functions. When the imported convergent bodies are displayed, we see that they are not in the correct positions or relations with one another. This could be the results of the scan origin or orientation. I'm also changing the color display of these imported parts for viewing distinctions. Using NX measure and move commands, we can quickly resolve this matter. When measuring distance, make sure the point on face option is enabled. This will provide users the option of selecting convergent body surfaces. Once the major broken pieces are in relative correct locations, the missing smaller parts will not be critical to obtain. Rather, we will use NX extrude, the sketch command, to resolve it. We will now define where the sketch will be placed and add rectangular sketch curves to those open areas. When that is done, we will just match up the thickness of the material and unite them into a single piece. Using a normal NX command in conjunction of convergent modeling body is an advanced technique that many other CAD systems cannot replicate at this time. NX will recognize that union of convergent body to normal solid body resulting in the new convergent body when Boolean operation is taking place. To satisfy the manufacturing, the field repair work, we will now create a bounding geometry by selecting all 6 extreme surfaces of this convergent body to represent manufacturing blank stock. Once again, we are using normal NX command, a bounding body that will enclose the select NX geometry. In this case, several convergent surfaces. When the stock is properly defined, we can increase the material of any bounding faces individually or uniformly. The next critical step is transfer that convergent body back to NX facet body for the generation manufacturing toolpaths. Now the part is set on the machine table and the stock is displayed. We will now use the NX manufacturing simulation control to simulate toolpaths and material removal. Due to the time constraint, I sped up the display so we can quickly see that the shape or the geometry of the convergent body from the STL import. The result of this manufacturing process is now coming to view through this unique engineering workflow. This concludes our quick tips today. This is NX.